when I say spontaneous, you should automatically think negative delta G, exergonic, energy leaving. All of those words go together. When I say endergonic, what I mean is that the reactants have less energy and the products have more energy. So this would be taking something like carbon dioxide and water, which have lower energy, and building them into glucose, which has higher energy.
Okay.
This is an energy consuming reaction or process. And for plants, that energy is coming from the sun.
Okay.
For us, when we do endergonic chemical reactions in our cells, that energy is coming from where?
Food.
Right, from food, ultimately from food.
And then ATP.
Directly from the ATP molecule. Yeah.
Okay.
Yes.
What's your y-axis on that?
Reactants, products.
The
Y-axis is energy.
So what would the top be like in terms of like entropy?
What would the top be?
Yeah.
This would be a high entropy
So,
state.
like,
This would be a
it's
lower
low
entropy
energy.
state. Huh?
I don't get what it means by like energy. So like energy released.
Energy stored in the covalent bonds, like the potential energy in the electrons.
So the energy in the products and energy in
Yep,
the
exactly.
So if it's low energy, then it has.
If it has low energy, it has high entropy because the universe wants to move to the lowest energy state possible. Right? Molecules don't like being in high energy states because it makes them unstable. Molecules would rather be stable.
For the exergonic again, the reactants have more energy than the products, and the difference you talked about, like difference.
The difference in energy in an endergonic reaction, this represents the energy that must be absorbed to get this to happen. For the exergonic reaction,
Oh,
this
it's what's
is
released.
exergonic. This difference is equivalent to the energy that was released.
Okay.
The majority of that released is heat, some of it released and captured by the cell to do work.
What would be the definition of exergonic and endogonic, right?
Endergonic,
Endogonic.
reactions that either consume energy, if it's endergonic, or release energy, if it's exergonic. Yes?
Oh, yeah. If it has lower energy, someone just heard that.
For the products have lower energy than the reactants. So this is exergonic. Delta G is negative, which means that some of the energy is going to be free energy that the cell captures.
Okay.
Remember, free energy is basically non-heat energy. It's energy that the cell can actually use. Most of it is released as non-free energy. Most of it's released as heat.
So does that mean if it has, okay, so it has more free energy than it's lower entropy?
This is moving from a state of low entropy to higher entropy.
Okay.
And anything that moves from a low entropy to a high entropy state is releasing energy. Yes?
Wait, so is the y-axis just energy and the red line is just